Unit 1, Lesson 3, Operation Functions Part 2. We're focusing on multiplying functions. Okay, when I opened the class, I just kind of teased it a little bit. I said, now when you multiply, you can see your degrees are going to have more chance of changing, okay, than we're adding and subtracting. So things get a little different. So let's just look at this here. So we're going to do that same type of thing. We're going to plot the points real quick. But simply, we can do this quickly. You guys can do that very quickly. Negative times negative, we got 49. Put that 49 there. Negative 5 times negative 6, 30. So we're just filling these out. 15, 4, negative 3, negative 6, negative 5, 0, 9. We're just multiplying f times g, right? Okay. So we'll go ahead and look at just plotting these. I don't have a 49, obviously. We don't have a 30, so it looks like we might have to start at the 15. So the 15 is at negative 2. So negative 2, we're at 15, so way at the top here. Negative 1, we're at 4. Zero, we're at negative 3. One, we're at negative 6. 2, we're at negative 5. So you can see it turned, right? I was at negative 6, now I'm at negative 5. So there's a turn there. So that's something to note. 3, we're at 0. And then 4, we're at 9. And I'll get all the way here. And all I was doing, if you're lost already, I multiplied f times g to get this value. My points are now, this is a point of my new function. These are all points. These ones weren't on there. This is my first one, and I plotted these. Plot those points right there. So we go ahead and connect that now. And you can see we have a parabola. That was not too bad. Okay, missed the bottom one a little bit. And so we had two linears, and their product was a quadratic, which makes sense. Two linears are degree of 1. You multiply 1 times a 1 for exponents, you have a 2. Okay? So it makes sense the output was a quadratic. Okay, I'll give you a second to touch up your graph real quick. Some of you guys are still drawing and finishing that, and then we're going to answer the questions below it, but I have to move up. So it says, now they tell us what the functions are. So we plotted the points, we completed the table. It tells us, oh, those functions were 2x plus 1 and x minus 3. So go ahead and actually simplify that expression in terms of multiplying. So if we're doing f times g, let's go 2x plus 1 and x minus 3. Right? Because we're multiplying them. Well, we're multiplying two binomials. How do we do that? FOIL. We've got to FOIL it out. 2x times x, so that's your 2x squared, negative 6x, x. If you use the box method, a lot of my math 20s were taught the box method from I'm not sure who, but you can do that. You just line them up. It's a different way of organizing them. Okay, so now it's combined like terms. So fg of x, that's how you write it, right? Fg of x is 2x squared minus 5x minus 3. Okay, so we're going to go ahead and just skim through put in your calculator, verify it. It will be the same picture we have above. We already did the hard work. Okay, I'm confident you guys can plug that in your calculator and see you get a quadratic. What's the domain and range of f of g? Okay, so we might have to do our calculator for this one, for fg, because we're doing range. We need to know the what? You know that minimum point. So if somebody wants to do that for us, that's good. We'll go ahead and do the domain real quick. Domain's the simple XER, right? We have a parabola, so it's growing forever laterally. Okay, so somebody help me out and give me that minimum value if you can. Is that exactly the turning point? I just wasn't sure if that's the exact turning point or not. We want to make sure. Okay. It's negative 6 what? Yep, okay. Negative, so then that's a good number. It's a whole number. So then we can just say, we'll do it in both, let's do interval 2. So it'd be negative 6.25, you said? Oh, 125. Okay, to infinity. Or we can do in set builder. We can do y bar, y greater than equal to negative 6.125. There's your two options.
Why is the first bracket
Yep, it should be. Yep. Good job, Cassie. Should be. We are including it. I included it on the inequality. Okay, good.
Will we have to show both of those?
No, I just ask for one, or if you doesn't say one, you can put either.
What do you prefer?
I'd probably prefer interval myself. So calculate the value of fg of 8 in two different ways. So the two different ways you could do the 8 in here and here and then multiply, or you can do it into right here and just get what you get. Okay? So that's the two different ways. So let's put 8 right here. So we're going to have 2 times 8 squared minus 5 times 8 minus 3. Yeah. Okay, we can go after the lesson. Okay. So we have 64, 128 minus 40 minus 3. So our value there is going to be 85. Good. Okay, just so we can keep going quickly. Got those guys trying to leave here. With 85, if you plugged it in to them separately and multiplied, you would have got the same thing. Okay, so we put 8 in here. It would have been 16, 17. 17 times 5. Well, what's 17 times 5? That's 85. So you would have got the same thing if you plugged it in before the multiplication. Okay. All right, complete the statement. In this investigation, the product of two functions whose graph or straight line is a, what type of function do we get? Quadratic. There we go. Now we're participating. Quadratic. Okay. So this question I don't like as much because they asked two graphs that are straight lines. Well, what are straight lines? You can also have y equals 5, right? Because y equals 5 is technically a straight line. So that would be an example of where you would multiply 5 times 2x. You would get 10x. You wouldn't get a quadratic. Okay, so if you didn't have a slope is what I'd say. No slope, and you did it, you wouldn't have a quadratic. Okay. Anything else? Now we're just doing the applied example and we're done. Okay. Let's practice. This is the main part right here. So that was the investigation. Now this is like the work, okay? So let's say you didn't understand the investigation. If you understand this, you're fine. Why don't you go and try these. I'll pause the video. Okay, so you're going to do f minus g, f times g, f minus g of 16, so just use that. F times g of 49, just use that. Okay? So the f minus g, let's go ahead and do this here. So that's going to be 2 root x, 3 root x minus 1 root x. Negative 2 minus a negative 5 is plus 5, so this right here is a plus 3. That's that one. F times g. I like f times g. Why is f times g going to help us out? Because we'll get rid of some of those root x's, right? Because root x times root x is just x. Okay, remember that. Let's look and see. Well, you're going to times. You have to FOIL still. Is that what you're asking? We saw it's still a binomial. So 3 root x times root x is just 3x. Okay, because the 3, that's a 1, right? 3 times 1 is 3. Root x times root x is x. Are we okay with that? We're doing this in Math 20 right now. So if you do root 5 times root 5, guys, you know you get root 25, which is 5. So the pattern is, if it's same, it's just that number with no radical. Okay. Okay, the next one, negative 15 root x. 3 root x times negative 5. Negative 2 times root x. and then negative 2 times negative 5. Now we just have to simplify. We have two terms. We have negative 17 root x. You can kind of see why they gave you the 49. See where the 49 is going? We're going to square root it. Plus 3x. Oh, no, sorry, we have three terms. Plus 10. Technically, I just put the radical in front just because it's the one I want to get rid of first, but is that in descending degree order? No, right? What's something with a radical's exponent? Does anybody remember? Not negative 1/2, just positive. Yeah, 1/2. If it's on the bottom of a fraction, negative 1/2, right? Okay, good. Okay, so that's 1/2, that's 1. Okay, so that's how you do that. Now we just plug the 16 in. Okay, what's the square root of 16? 4 times 2 plus 3, 11. Okay. Square root of 49, I'm going to need help maybe. Let's see here. That's 7. 70 plus 49, 119, I think. 119. 49 times 3, 120, 147. And that. Okay. And we're finishing it off, and you guys can get out of here. So we got, what's this? 28? 38? There you are. Okay. If those of you guys are sticking around, want to go over that closer, we will, but that is all for lesson 3 today.